Hello, this is Mike at GameFromScratch. Welcome back to our ongoing LibGDX tutorial series. Today we're going to start part 2 of our look at LibGDX 3DX support. Specifically, we're going to look at loading in a 3D model and playing a named animation within it. The model is obviously created in an external program, and the animation as such is done also in that program, be it Max Maya or Blender, Softimage, whatever that can support FBX export. Will work for you. In my case, I actually created the model using Mixamo. I used a product called Fuse. I have a tutorial on using Fuse to make characters. If you want to see the process I used, just look at my channel. You'll find it in there. It's Mixamo Fuse. It's a quick character creator, and then Mixamo itself provides a lot of pre-skinned animations for you. So that's the file I'm going to use. I'm going to make this available at GameFromScratch.com, so you can download the zip file to go along with what we're actually working with here. Or obviously you can use your own FBX file, assuming you have one. But this is the guy we're using here. It's an animated zombie walk. And first thing we need to do is convert it into a format that LibGDX can use. First off, let me apologize if my voice cracks or I lose it otherwise. I'm fighting off a bit of a cold right now, so this is kind of painful for me to do. So I have to pause for drinking and such every once in a while. So if I'm a little off on this video, my apologies up front. So anyways, you're going to need this converter to continue. And it's called the fbx-converter. And it's available at libgdx.badlogicgames.com/fbx-conv. Just download the zip, extract it, and the executables for all the platforms are available inside of it. If you just search for fbx-conv in Google, the first hit is what you want. Just link to the binary section and go ahead and download it there. This is the zip file we want. I've already downloaded and extracted it. So we're going to use that to convert our FBX file. I also downloaded the FBX file again from Mixamo already. You can get it from wherever you want. Just keep in mind, when you're exporting from Blender or Maya or Max or whatever, there's going to be some finickiness. For example, Blender and Maya and Max all use different up coordinates. So you may have to rotate your model. You may have to set up things specially for textures to work out right. We're actually going to run into a problem today. I'll show you how to work around it. But you're also going to need all your textures individually. They can't be packed in. So if you're not working from the same source I am and something goes wrong, it's probably how your model was exported. Some functionality is not supported. It's finicky. This is true of all tools at all time working with 3D programs. There's always some issues. So I would recommend downloading the zip file I've got to work with your code to make sure that you have it working right. And then from there you can start working with your own assets, etc. If you are going to use Blender, go to GameFromScratch.com's LibGDX tutorial series, and there's actually a one on explicitly exporting from Blender for FBX export. So it shows you how to set up your texture maps correctly, how to set up animations, how to name animations, etc. So if you're working in Blender specifically, I've already got you covered. Just head on over to GameFromScratch.com and check out that tutorial. So anyways, we have our FBX file, we have our FBX converter. Now let's go ahead and do our conversion. Go here. So here's everything exported into my downloads folder. I'll open up a command prompt. I'm going to need to go there. FBX convert. Okay. And the next thing is I went ahead and I downloaded here Fuse model walking. This is the animation we're going to use here. Let me just load up Blender quickly. Alright, let's get rid of the square, and we'll go ahead and do an import. And it's an FBX file. And it's in my downloads folder. Where did you go? There. And that guy. Alright, so here you go. I'll go switch over to texture mode so you can see what we're dealing with here. Here is... Oops, did not mean to move him. Here is the model we're using. It's a zombie walking. I think it's got about 125 frames, so I'll shorten that down and play the animation. And that's it. So that's the model we're going to export and get it over to Blender. Now there is one catch. Like I said, all of the textures are actually embedded in the FBX file, and we don't want that. We want them all to be added to our assets. So we're going to have to break those out. Fortunately, if you do load it up into Blender, it's extremely easy to do. Just go to File, External Data, and unpack all into packed files to unpack. Alright, was not expecting that. Go to UV image editor. So you can see here, here's all the different textures that are part of it. Save all images. Alright, now if I head back over to my downloads, here's all my various textures. So we're going to go ahead and we're going to need these. So I'll just start right off the hop, grab all of them, and I've already created a project. So they're going to go into our assets folder right here. We'll just get rid of the, don't need the bad logic logo. Yeah, that's fine. And just grab them all and throw those in the assets. All right. So there's all of our textures. Now what we need to do is convert our file into our FBX compatible format. And that's done from the command line. It's actually located up a directory. Here, I'll move it into the same folder just so everything's even easier so we don't have pathing issues. So we want this guy. And we will throw it in here. And we'll just call it model. All right, so it's a command line to do this conversion. You're just running fbx convert. Obviously, it depends on your platform, but in this case, we're doing Windows. And then sometimes you need to flip the UV texture, sometimes you don't. If your textures don't come up showing up correctly, use this -f command. We'll start without it. So model.fbx, and it'll run. And it'll have generated this G3DB file. Now we just grab it and drop it in our assets folder too, like so. Okay, so there's our stock model and the different assets for it. The different textures that are needed for it. Unfortunately, like I said, the FBX had them all embedded, and you can't get away with that. So you're going to need to break all your textures out into individual files that can be loaded by the Fbx loader in LibGDX. So now that we have that asset out, let me just show you something else quickly. You have another option here. We just export it as a binary format, but a lot of times you're going to have incompatibilities or issues with your file. It's just going to come up. Sometimes things aren't going to import the way you want it, etc. Now you also have the option of, I think it's T. One second, I'll actually verify. Good thing I verified. It's actually O. So the output format, and you can specify G3DJ, and the J is for JSON. So now we run the same thing, and now it created this G3DJ file. Let's go ahead and grab it too. You only have to do one or the other, but it's nice to have both. All right, so now it's in the file. This is a binary format. This one, however, is in JSON format. So you can open up and you can actually see it. And this is actually convenient because we're going to have our animations in here. And I know from a fact that Mixamo called it Mixamo.com. But see, your animations are simply a JSON format, so the ID is Mixamo.com. And when you're going to access it, you're going to need to give that name. And figuring out what the heck this thing was called, without looking at the ASCII formatted version, this JSON formatted version here, I would have never figured that out. Generally, you would have made it yourself and given the animations names yourself. But since this was exported from, well, Mixamo.com, what name they chose to use is unknowable to me, and we're actually going to need this in a bit. So that's sometimes why this format's very handy. Otherwise, it's a very straightforward format. This is all of the vertices that go and make up your model. Obviously, this model is quite big, so this file is quite big. And then now we're into the faces that those composed from those vertices. So the indices for the triangles that make up the actual mesh. And then after that, I think this is normal datas. And then your bones and your hierarchy of your character. And then eventually in here, you'll have your material hierarchies, etc. So all the information you want is in here. This is a JSON format version. This is the binary format version. Debugging purposes, use this guy. For otherwise, use this guy. All right. So now that we got them both, let's go take a look at our code. So we have our converted 3D model in here twice, and all of the textures it needs. Now we just need to make the code. So let's head on back over here. Let me just set up a run configuration, and then I'll switch into presentation mode. So this is an application. I'd want the desktop and core assets is the location and desktop launcher. We've done this 100 million times already, so I won't explain it. There. So now we have a run configuration. I can't run it because I killed the image file that it needs to run. So we're actually going to go ahead and get rid of all this code anyways. Let me just switch over here into presentation mode now. Ta-da! Alright, now let me just... let's get rid of everything. Okay. So now we're going to go ahead and implement our code. We're going to need a number of things as part of this, this class. So let's add all of our member variables first. We're going to need a camera. Saw this in the last one, so nothing new here. We are going to need a model batch. Again, nothing new here. Model. Let's see, what else do we need? An instance of the model. Guess I should give it a name. The environment. And an animation controller. That is the only thing that is new. And this is for playing back our animations. I'd call it controller to be consistent. Okay, so that is our member variables. Like I said, most of it's new. The only thing that's really not new there is the animation controller, which we'll see shortly. I deleted my override, so let's get create in here. All right, and for create, a couple things we need to do. First thing is let's create our camera. I'm going to use 75 degrees field of view, gdx.graphics.get width, gdx.graphics.get height. So there's our camera. Let's see, next we got to position the camera. All right, so I'm going to use a bunch of arbitrary values here because I kind of know what size my model was. The dimensions in your 3D world are pretty arbitrary. They can be 1 meter, 1 foot, 1 centimeter, 1 cubit, 1 whatever the hell you want it to be. Since the actual modeling was all done in Mixamo or in Fuse, they set the dimensions for me. I could easily bring them into Blender, change the scale down, set it to a size I want, etc. But I'm just going to go with their numbers. And as it stands, our character is about 100 units high. And actually, it's a little bit smaller than that, but we're going to use those values relative. So the things I'm going to set here for positioning the camera, etc., are all relative to the model size. So they really mean almost nothing. So we're going to set the position of the camera, 0x, 100y, and 100z. And then now we are going to look at the origin, sort of. Oh, sorry, look at. So we want 0. And then 100, and then 0. So we're going to look at the origin and then up a bit. All right, and now let's set the near and far plane of the camera. So how far to start and stop recording. Near is basically 0, so 1.f. The far is, I don't know, 300. Again, somewhat arbitrary values. Now we need to create our model batch. Equals new model batch. And that's actually all we need right now. Next thing we are going to need to load in our model. You know what? We'll use the JSON one. So we're going to need a JSON loader. So UB JSON reader. This is for decoding a JSON file. JSON, by the way, is JavaScript object notation. It's just basically a JavaScript file stored as data. Very common from the HTML5 world to store things in JSON format, and it's sort of spreading beyond. It's kind of a lightweight XML. XML used to be used for everything. It was way overcomplicated. JSON strips it down to the bare essentials. So it's basically just data stored as JavaScript. So let's create one like so. So now we got our decoder. We need a model loader, G3D model loader, and we will call that model loader, and create a new one. Oops, hey, you. G3D model loader, and we pass in our JSON reader, like so. So it will use that JSON decoder to load the model. All right, now we got our model loader. Let's load the model. So already created the model earlier, equals model loader dot load model, and gdx.files.get handle, and I believe it was called, I have no idea what it was called. All right, one second. Model. Yeah, that makes sense. Model dot g3db, and that is internal, like so, and close, and that is not a semicolon, that is a semicolon. All right, so that loads our model using the model loader, which in turn uses the JSON object reader. So that is how you load the JSON formatted one. There's also for binary, just passing a different parameter. So if you go G3D model loader, I suppose I should do the new so we can actually see. You'll see you could pass in base JSON reader. It takes the JSON reader out of the way. Oh, so either binary or text. Okay, so ignore everything I just said. It works either way. So we need to create JSON reader regardless. Okay, so the model is loaded. Now we need to create an instance of it. The same way as we used the shape builder and then we created an instance of it, you load one model and then make many, many instances of it. So if we had 100 of these zombies being created, each different instance would be a model instance, but you would only have one model. So our model instance is a new model instance, and you pass in the model, like so. So that loads up our model. Let's see. Some quick positioning of the model. Model instance dot transform, and I'm entirely certain why I did this. I'm moving it 22 down the Z. I think that's probably cut and paste legacy. I don't really need to do that. I'll get rid of that. No logic behind that. All right, so finally we need to set up our environment for lighting and such. Equals new environment, and set up our light dot set. Again, this is all from the previous tutorial. So color attribute, and that in turn is a color attribute dot ambient light, like so, and 0.8f, 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 my whitish light, 1.0f full alpha. There, so we have a whitish light. And finally our animation controller. Controller equals new animation controller, and you pass in the model instance. And now we use our controller. Remember when we looked at the file format earlier and saw that mixamo.com was the name of the animation? Well, what we want to do is kick off and start playing the animation, and in order to do that, we use our controller. Controller dot animate. No, that's not right. Set animation. We're going to use by name as opposed to, if you look back, you've also got another of sets here that you can control keyframes, individual values, a lot more detail, but we're just going to kick off the animation by name. With set animation, and we just pass in the name. Remember, it's mixamo.com. Not sure if that's case sensitive or not, but let's be consistent. And the loop count. And what we want to do is loop forever. So just go ahead and pass in a -1 there. If you passed in a 1, it would play once. If you passed in a 2, it'd play twice. If you passed in a 6, I bet you know how many times it would play. That's right, 8. I'm kidding. All right, so that is the end of our create function. So next up, you know what? I'm going to be a good Samaritan, and I'm actually going, I'm going to go ahead and dispose as well. So on our dispose, the big guys here, the model batch is a disposable, so get rid of it, and the model. is disposable. The instance is not and will not leak. So that's just me cleaning house, as I rarely do. And finally, let's implement our render call. Get rid of that. Render, you know what? It's pretty much the exact same logic and code that we had before. Boils down to gdx.gl.gl viewport. Why did I set this? This should be... Oh, because I don't use a camera. Why am I setting this? This is old code. I'm not really remembering why I did this part specifically. So you may not actually even have to do this part. I'm not sure why I did it. Anyways, that's setting the GL viewport. The camera should be doing this anyway, so that line of code right there is probably superfluous. So you could probably just completely get rid of it, which I may do in a moment just to see if I'm right or not. So GL dot clear the color. Clear color, and let's clear out to black. Or is that white? That's white. Absence of color is black. Full color is white. Yeah. So clearing to white. gdx.gl clear. So that sets the clear color. So gl.gl clear. And we want to pass in gl20 dot color buffer bit. We're clearing the color buffer bit. And gl20.gl underscore depth buffer bit. So clear out the depth buffer and clear out the color buffer. So basically wipe the screen and done. So now camera.update controller. So you have to do it on a per frame basis. You got to update the animation controller so that it ticks forward in time. As you might guess, you have to actually pass in the time, which we can get by gdx.graphics.get the delta time, like so. And now our model batch begins. Model batch.begin using our camera. And then model batch.render, and we are going to render our model instance like so. And then model batch.end. Very familiar, same stuff as before. This should be about it. Alright, I have a yellow. What is a yellow? 3 warnings. Who cares about warnings? Oh, I never used environment. Environment is set. Comma. Camera render model instance. Comma. Environment. There. So we actually used it for a change. Now, in theory, this is a big maybe. We should be able to run this. That's a lot of code to write to have it just work. So we have white screen. That's not giving me a lot to work with. So I didn't get an error. If there was a problem with the GDB file, it would have errored out. Let me just get out of presentation mode for a second here. Let's try the 3DJ file, see what it does. Boom. All right. Does not like the format of that file. Okay. Let's go back to the binary version. Binary version is just fine. Now, remember what I said ages ago? You may need to call flip. If your textures didn't show right, let's find out if that's true. All right, so there I flipped it. So make sure it's modified. Yeah, that guy. Go on our assets and overwrite. And nothing. All right, that's just irritating. Why are you doing this to me? Okay, debug mode. Be right back. Okay, this is going to be sort of unsatisfying here answer, but um, I'm not entirely certain why this didn't happen. I took the development version of the file as opposed to the download version, exact same file. It's just I happen to use the converter on my Mac as opposed to my Windows machine, and it works just fine. So I'm not entirely certain what the deal is. It's something to do with the actual file itself. Um, but yeah, so um, I've replaced it with the one I downloaded called Walking 3. Let me just go ahead and run that. So this is the same file. Instead of being called model, it was the original file name converted over. It might be in how I exported it from Mixamo. I think in the one case, I did a straight FBX version. Here, I'll show you quickly what I mean. When I select a file here, I can grab it and go download FBX for Unity, or FBX for Unreal. And I think I switched between them on different platforms, and something in that caused the entire process to break, unfortunately. So ultimately, that's the issue here. It's not a very satisfying answer, but when I brought this guy in and changed it, let me just go and give that guy the same name, refactor, rename model, do refactor. All right, so this is the original actual model file. So this was something to do with the export process from Mixamo. And unfortunately, like I said, you are going to have issues every time you deal with 3D models. It's just part of the nature of the beast. And that's why that the JSON version can come in handy if you're trying to debug why it didn't work out right. But in this case, I just basically swapped it with the original I used. And now I go ahead and run it, and you see there's our model. And that's playing an animated file. You can also, there's a little bit more you can do. We can set an animation listener. Here, we'll do that quickly. I'll show you just for the sake of thoroughness. As part of our set animation here, like so. So you can set this animation listener as well. It's going to be passed into the animation. And this is what you would often do. If you have a jump that follows into an idle or a walk, you want to switch the animation after the fact. You can use this animation controller to handle that. In this case, we're just going to go to the app.app.log because we're looping forever. Info, comma, animation, ended. Like so. And we'll just go ahead and play that. And there's our video, and loop. Oh, duh. Okay. Let me show you what I just did. I just put an on-end handler in a looping animation. That's mildly stupid. Let's try it again in on loop. And then it might actually do something, because the looping animation is obviously never going to end. All right, so there it just looped, and there you see the animation listener kicks in. You would obviously use this for, you probably have a bunch of, you'd create a quasi-state machine of all your different animations, and if one queued off the other, you can set it in the animation listener to handle it after the fact. But that's kind of it. It's very simple. You can play around a bit. The controller has a little bit more options too. So you saw earlier, you can pause the animation. You can transition. You can change the speed. That's about it. As you can see, the offset, so you can jump a certain frame in. You can change the speed you're playing it back at, etc. You can get the current animation. Yeah, that's kind of about the same. That's the extent of it. The only thing that isn't really covered there is blends, and that's a little bit beyond what I want to talk about, so we'll leave that for a different day. So essentially that's it. That is what is involved in loading a 3D model into LibGDX. Fairly simple. So as you saw in our earlier tutorial, the 3D stuff all works the same. So instead of getting a model instance by using a built-in function, we're getting it from importing it. And we'll start at the very beginning. You use the Fbx Convert, so fbx-conv, Google that, download the binaries, use those to pass in. If for some reason your textures are flipped, do a -f to get them to show up properly when you're doing your conversion. Then you take the generated G3DB file and all of the texture images independently, throw them in your assets folder or a subdirectory thereof. You set up your scene as normal, use a model loader, pass in the formatter to read it with, so in this case the UB-JSON reader. Sorry, that was my mistake earlier. The BJSON. BJSON is the binary JSON as opposed to the text JSON. So that's the mistake I made earlier on. Sorry about that. There's two different kinds of JSON readers available. This one is for the binary JSON files. So anyways, you go ahead, you load your model using the model loader.load model. You create an instance of your model, and then you set it to whatever animation you want. Once again, the animations are embedded. If you go to GameFromScratch.com, there is a guide to actually naming your own animations if you use Blender. Otherwise, naming them in... I actually have no idea how you do it in Max anymore. Used to be something in Max was actually pretty lousy at, but I think functionality has changed there. But you can also, a lot of times, what is commonly done is it's done via the timeline as opposed to names. So you would load it up as animation, and then instead of doing it this way, remember we saw earlier the controller can be set start here and go to here. So what you could do is you could load up 500 frames of animation where it's like 30 is the walk, 50 is the run, etc. And then you play your animations by doing jumps as opposed to by name. So in this case, we're doing set animation using name. If you have all of your animations in a single timeline with a single name, then you'd use it by offset. And then here would be potentially how you would do it. So this is what we see here is we're setting up an animation listener to listen for when the animation first is done, in which case we do nothing, or when it loops, in which case we just log it out. And then you run that once again, and here is the end result. Our model nicely loaded. Again, it's all taking its dimensions from the way that it was created. So the sizing you use is very important. You're going to want to get a very consistent size for your game world. You're going to want to author all your assets and deal with them all at the same size. But the actual units you use are completely up to you. So that's what these positions and such are, this 100 bits. It's just because of the size that this thing was created and exported out as. As you saw from the catch we had earlier from it being FBX exported to the wrong game engine style, causing it to not work. Unfortunately, that is the nature of the beast. You have a lot of that when dealing with model exporting. Once you get your pipeline down working correctly, it's no problem. But once you start pulling assets from other people, you can start running into this, why is this not working? What is the problem here? Why is there an error? And normally it comes down to just basically being lost in conversion somewhere. All of the file formats, Collada, FBX, everything that basically is simpler than the old-fashioned OBJ format, there's going to be complications in dealing with it. It's just an unfortunate nature of the beast because these formats are so complicated. But for the most part, the FBX converter does a pretty solid job. So hopefully that was useful. Thank you very much. Have a good day.